Today on the Perception and Action podcast, how does the presence of the yips influence motor coordination and throwing? Do the muscle synergies used to control the abundant degrees of freedom in our motor system change? So it's time for a call to action. Hi, this is Rob Gray from Arizona State University. I've been on a now over 25-year journey as a researcher, professor, and high-performance consultant to understand how we acquire and adapt our perceptual motor skills. Welcome to the Perception and Action podcast, where I discuss how psychological research can be applied to improving performance, accelerating skill acquisition, and designing technologies. Now on to the show. Hi, everyone. This is Rob Gray from ASU and the Perception Action podcast, back with another article review. In this episode, I want to look at a really interesting paper looking at the effects of the yips on motor or muscle synergies involved in throwing. And this is a continuation of a study. This is another study by the same group that published one I reviewed a few weeks ago on motor imagery ability in players with the yips, a group from Japan, and that was reviewed in episode 477. So the one I want to look at today was published in Nature, no less. Nature Scientific Reports, looking at the differences in motor synergies between yips players and ones without. Okay, so that's what we're going to look at in today's episode. So in previous research, there's been a lot of studies that have looked at kind of the motor of demands and the motor issues associated with the yips. A lot of them using EMG, motion tracking, etc. But primarily they've been focused on single muscles, right? Looking for effects of muscle tension, things like that, something called dystonia, where you have a tight muscle. And very few of them have looked at multiple muscles, multiple joints to get into issues related to coordination, right? Which is something, of course, we're going to be really interested in. And so that's what this study wanted to get into, right? They want to look at the effects of the yips on motor coordination, right? So if we talk about, let's remind ourselves, I've talked about muscle synergies on the podcast before. Let's remind ourselves what they're involved. So the task we're looking at here is throwing. The way to illustrate, I like to illustrate this by looking at three types of variability. The variability you have in practice, right? In pitching or throwing, do you always throw the same ball? Do you always throw from the same distance? Or do you vary those things? Do you vary ball weight? Do you vary throwing distance, etc.? Variability of practice. Then we can separate the movement variability into two types, right? What Bernstein called the elemental and essential variables, right? So the elemental variables are the degrees of freedom in the actual movement of your body, right? So what angle is your elbow? What's the maximum extension of your forearm? What's your knee angle when you release the ball? So we're talking about kinematics, right? Your body, and the variability we're talking about is within a single individual pitch to pitch, right? How much variability are we seeing? Okay. And then we have a variability in what Bernstein called the essential variables. So the essential variables here are some aspect of the movement that we're trying to control and regulate more rigorously. And what we're going to look at here is the position of the hand at the point the pitcher is releasing the ball, right? That's the essential variable. And then we want to look at how that relates to outcome variability, right? So where the pitch goes. Does the pitch consistently go to the location you want it, right? That's what we want. So obviously, we want performance outcome variability to be low. We want you to consistently locate the ball and hit your target. How do we get there, right? Well, I've reviewed this in past episodes. What we know from some of the research I've done is that performance outcome variability seems to involve low variability in the essential variables, right? If you look at the position of the hand at the release, all the different ways you can measure hand position angles, it seems to be very, very consistent, very, very repeatable. There seems to be relatively low variability in these essential variables. And I think that makes sense to most people. The question comes, how does that relate to the elemental variables, right? How do we get the consistent release point? One thing we could do, right, is one way that we could achieve this is, of course, have low variability in the elemental variables, i.e. a repeatable delivery. if we threw a ball with the same elbow angle, the same shoulder angle, every pitch we make, that would give low variability in the elemental variables and presumably low variability in the essential variables. So we want to keep the movements of our body as consistent as possible from delivery to delivery. And obviously, if you know me and you know the work I've talked about a lot, that's not how we're going to do it, right? What seems to happen instead, right? What we see is what the alternative is we could have a relatively high variability in the elemental variables in the form of motor synergies, right? So our elbow angle is not going to be the same from pitch to pitch because our elbow angle on any pitch is going to depend on our shoulder angle on that pitch. So if we overextend our shoulder, we're going to use less elbow, right? So the body parts are going to work together to keep the hand release point on target. So we're going to need a relatively high amount of variability in the elemental variables to achieve this low variability in the essential variables, low variability in outcome, right? And of course, for those that are following along, this is essentially Bernstein's idea of repetition without repetition, right? We repeat the outcome, we repeat these essential variables at release point, but not by exactly repeating the movement. We repeat them by developing these motor synergies. And for him, and there's a study I always say by Matsuo that used the permutation method. That's exactly what they found. Their quote from their study was, it implies that regulating variabilities rather than reducing the variabilities are necessary to pitch accurately. So restructuring the variability to develop these motor synergies as opposed to eliminating all the variability through a repeatable delivery. That's repetition right with repetition, right? And of course, this is in Bernstein's model of motor learning. This is the highest stage of. So when you're learning a skill, you first go through freezing. You isolate. You don't move or you couple certain joints. Then you freeze certain movements. Then his highest level of motor learning, my simplified version of his model, was when you develop these motor synergies, where the body is naturally self-organizing and working together, right? So the muscles can compensate for each other and achieve these things together, right? So that's what he found. That's what he proposed, and that's what we seem to find in pitching, right? So in pitching, well, I'll show you those in a second, right? So continuing on with the authors, we know there's several indications that motor synergies can get affected by different things, right? So we know that people that have a stroke or a spinal cord injury, it changes the motor synergies involved in walking, okay? What tends to happen is you get these kind of reduction in the number of synergies, right? You seem to get things grouped together that weren't before, okay? It's almost like a type of freezing going on, right? Way you can think about it, I call this the creeping hand of pressure in my second book, right? You can think about it, when we're getting to the yips, what seems to be happening is something is you're trying to consciously control your movements in some ways. And it's just not letting yourself naturally self-organize into these motor synergies. You're disrupting them, right? And so the authors proposed to look at the muscle activity and the motor coordination in baseball players with the yips, right? And they proposed that players with the yips were going to see some differences in the synergies, in these motor synergies, because of this kind of attempt to do this top-down control and disruption of self-organization. Okay. So what they had in the study, returning to the methods, they had 12 players, 10 with reported symptoms of the yip, 10 that never had the yips. They had to for at least a month. The yips are classified usually as purely muscular versus kind of a type 2, where the type, which is type 1, versus type 2, which has kind of psychological, both muscular and where it's more of a choking, anxiety related effect. And then type 3 seems to have both involved, right? So they classified the players they were studying into one of these three types. And here's what they found. So the 12 players they looked at, you can see there was only actually one pitcher in the study. Players from playing other positions get throwing yips, right? And you can see the duration, how long they've had it, and the types 1, 2, 3. You can see most players had were 2 or 3, right? So they had some psychological component to it, not just muscular component, right? So this is the population they used, right? They're going to throw a ball as hard as they can at a target that's 5 meters away. So they're not pitching off a mound; they're actually just throwing it. After a key challenge in studying the yips, right, and this is going to be important for this study too, is that it's actually quite hard to um, recreate the yips in a lab, right, in the experiment, right? How do you get the usually they're associated with high pressure, like a high pressure situation, the ninth inning. That's very hard to recreate in a lab. So oftentimes in these type of throws you make in a lab, people don't experience the muscle tightness, they don't experience anxiety. So they what they want to do is to measure whether they got any players to experience this. They also use motion tracking to divide the throwing into 4 stages: early cocking, late cocking, acceleration, and ball release, right? Very similar to the type of phases you see in a pitching delivery, right? So that's what they'll do. Okay. They used EMG data, so they recorded EMG from 13 different muscles on the body to investigate the muscle synergies involved in throwing. Okay. What they do, they take all these recordings from all these 13 different muscles, and they do what's called a K-means cluster analysis. What they do is they look at how many different, can we describe the activity of all these 13 muscles by looking only at 4 groups, right? Can we describe them? Can we group essentially the muscles that seem to be doing the same thing or working together, i.e. a synergy? So can we explain the movement of the whole body using a small number of components? So that's what a cluster analysis is trying to do, is trying to find these clusters of muscles that seem to be working together, right? And of course, those are the synergies, okay? In baseball pitching, previous research has found that you can describe all the EMG activity with about 4 clusters, 4 synergies. Anything above that doesn't give you any about explanatory power. So there seems to be 4 synergies involved in this movement activity that change as you go through those different phases of delivery. And the initial ones are involving the shoulder and the trapezius when you're doing that cocking. Then it moves down to into the biceps and triceps, right? Then moving into the chest and the delts, and then getting into the wrist and the lats, right? So each stage you can describe the main muscles involved in each of the clusters. So there's these 4 clusters seem to be involved, these 4 synergies involved in baseball pitching. And again, as I said, that's from past research. Okay. In terms of the actual study, what did they find? So as I said, they measured these synergies using the EMG activity. They recorded it, did this cluster analysis, found it. What they first want to look at was, does any of the players experience yips-like symptoms? Okay. When they were in the actual study, and they found only 3 out of the 12 reported they did. The ones they're going to look at, why player number 7 had excessive retraction of the throwing arm during the early cocking phase. So they kind of move the arm further back. Player number 12 had a temporary pause of the arm motion during the late cocking phase. So they seem to have this very distinct pattern. They're observing it, and they noticed it happening in these experiments. And this was actually confirmed kind of by people viewing the videos of them pitching. They seem to can see these kind of dystonic, these kind of tight, slow movements involved in the middle of the delivery, right? And so, I've worked a little bit with pitchers and yips in baseball, and what I've seen, right, what you tend to get as a pitcher is they've had experience with being wild in the past, the not hitting their target, and either that's led to being embarrassed and walking a ton of players, or even worse, hitting a batter and hurting them, right? And a common thing they report is the fear of letting the ball slip out of their hand, right? So they'll hold it extra tight, right? When they grip it extra tight, and this causes things like we see in these people a pause in the motion of the arm, extensive retraction. Paradoxically, right, holding it tight makes it increase the chance of it going wild, because you're you're using this top-down, almost freezing-like control and not letting the self-organization of the synergies get the ball on target, right? So that's kind of what we see. So that's what they saw. As I said, that's important to know. Only only three of the pitchers experienced any Yips-like symptoms in the actual study. But for most of the other ones, there probably wasn't enough pressure, not high enough stakes to induce it. Okay. So what did they find in terms of the actual synergies when they looked at the Yips versus the control group? Well, first of all, they found no differences in the number. For both groups, there was 4 that could explain. There's no significant differences in the muscles involved or the patterns, right? There was no specific differences in the specific muscle synergies associated with Yips that weren't associated with regular throwing. So they didn't find any simple patterns, right? And if you look at the data, this is just showing when the Yips occurred during the different parts of the muscle activity. They're very, very similar between the Yips and the control group. The lines almost overlap perfectly. Okay. So there's no overall pattern. So you couldn't really do an overall analysis comparing the groups like in ANOVA, like I've been kind of saying in a lot of this research, right? We need to look at an individual level. So what they did next was they looked at those individual players who experienced the Yips symptoms during their study. Okay. And they looked at their motor synergies individually instead of looking at the whole Yips group together. Okay. And they also, as I said, they measured state and trait anxiety using this questionnaire that all of us use that do pressure research, STAI. And they didn't find any overall effects of that, right? Again, but so they looked at these individuals. They did find, when they did that, they did find differences, right? For example, they found different levels of activation. For player number 7, they found different levels of muscle activation in synergy number 1. Okay. This because they're doing this excessive arm retraction was consistent with using different muscles. So they're using different types of muscles are coming together into the synergy at different phases in the delivery. But I won't go into super detail. If you're interested in what exactly they were, you can have a look at the paper. But the key thing here is that at individual level, players who were experiencing these symptoms do show this kind of change in their synergies, right? Player 12, you're getting a difference in the timing of the peak of the synergy. We're getting a little different, the weighting of different muscles. And so different kind of patterns, not a simple story I can just give you. They're delaying of transition from one synergy to another. So some sort of timing things, right? And if we look at, I know if you're listening, you can't see this, but here there's a good figure in the paper showing the synergies for the control group versus the 2 players who experienced the Yips. And you can see the timing, there's not a complete overlap anymore. I mean, they're occurring at different times. There's different peaks. There's different, on the left, there's different muscles involved, right, at different points of time. So we do see some differences in these key motor synergies. Okay. So they argue that, this study provides a novel finding that you do get changes in the motor coordination through the muscle synergies in the experiment when the participants experience the symptoms in the experiment. Okay. So they argue that this may be a useful way for understanding what exactly is going on in the Yips. As I said, this makes total sense from a control perspective, right? We are not meant to control our movements through top-down commands from our brain, right? We're meant to control our movements through self-organization, letting the muscles work together to get our hand on target. Letting our shoulder and elbow work together on their own, self-organized through a coordinative structure, all these things I've talked about in the past to get the target on point. When we introduce this top-down executive command to hold the ball extra tight or make sure it doesn't go off target, the same way that, as I called it, the creeping hand of pressure disrupts self-organization, we can see the same thing is going on here. So I think this is a really interesting approach to understanding the problem with the Yips, and I can show you the specific things that are happening, right? I think that's, which muscles are being involved, which phase of the pitching delivery, and then possibly you could imagine adding some constraints, right, to try to address some of these changes in the movement motor activity. I should point out there are also some other studies that have been done on. There's a fair number of studies I think I've talked about in the past on motor synergies and throwing and pitching. Right, there's an interesting study here that showing there's other examples of things that change your motor synergies. One of them is fatigue, right? The amount of activation, for example, in the pectoral muscle during synergy number 4, right? And the tricep, for example. So with the fatigue, you get these systematic changes in the synergies, right? You're getting this reorganization. In this case, it's the reorganization because the constraints are changing, the individual constraint of fatigue, right? So all these things are happening with the synergy. So I think this is a really interesting line of research to understand how these synergies change, whether their changes are functional and adaptive or whether they're non-functional. Right. There's some also baseball studies that have looked at after UCL elbow surgery, how these synergies change. Are you getting functional adaptive changes in synergies or ones that are potentially dangerous? Right? So I think this is a really interesting study, again, highlighting the importance of motor synergies in pitching, letting your body self-organize, muscles work together, not chasing the unicorn of a repeatable delivery with low variability every time. Right. That's not how we consistently get a ball on our target. Okay, that's it for today's episode. Remember, you can contact me at robgray@asu.edu or follow me on Twitter at ShakyWeights. To find out more about the podcast, please check out perceptionaction.com. Finally, to support the podcast and receive bonus materials, including a monthly coaches meetup, please head over to patreon.com/perceptionaction. This is Rob Gray from ASU. Cheers for now, and keep 'em coupled. Gone through St. Louis.